Good evening and welcome to the 29th annual exhibit of hydrogen fuel cell technology. We've been here since actually 1995 with very few interruptions talking about this industry. We welcome you to the Hanover Fair 2023. Have a seat, the drinks are on the house, and we're going to continue our discussion about the production of hydrogen, a fundamental in order to get to our goal, which is net emissions in an electrical grid, in an energy supply. I'll be talking to Wilko van Kampen, who's the CEO of Xintc, and we'll be talking about a really surprising innovation from my perspective. I've never heard about this before. Plastic multicore alkaline gas modules. Please welcome with me Wilko van Kampen. Mm-hmm.
Good afternoon, Brian. Hello.
Good afternoon.
Nice to see you.
So there have been companies, of course, that have been here for 20 years. I still ask this question because not everyone knows things, but you are an innovator. The first question, of course, is tell us about Xintc, where you're located, when it was founded, and what you people do there.
Well, thank you. Xintc is a small, versatile company established in 2009 in the Netherlands, with a bunch of dedicated technicians. Me as an investor and entrepreneur stepped in 7 years ago and to develop, let's say, this multi-core plastic electrolyzer system. We work from 3 different locations in the Netherlands. We have a very strong scientific team of people in Delft, in the west side of the Netherlands, also with a conjunction with Delft University. And we are producing our multi-core plastic systems in the east side of the Netherlands, near the German border.
What fascinates me about your technology, and you really have to visit the booth, which is B21, to see this, we've seen electrolysis just explode on this market here. It's a fundamental part of this display here, but they're all relatively comparable. There are various flavors, the PEM and the alkaline, but I've never seen something using plastics. I've never seen something with your particular design and also your conception of what the applications are. Let's start with the plastics, which really surprised me. A plastic, and we're talking about electrolysis here.
Yeah, sure.
Different
absolutely.
process, but it's still electrolysis. Plastic electrolysis modules. Why?
Well, electrolysis in general, I mean, this is nothing new. It's just the let's say, the use of the type of materials. We all know that for special, let's say, alkaline or even PEM electrolyzers, you use what we call critical materials. Some are even scarce materials. Well, the other thing is, of course, that the prices, instead of going down, of the materials, goes up and up and up. And even today, with this, well, geographical tensions in the world markets, we thought it might make sense, let's say, to use readily available and relatively affordable plastic materials. They are durable, they are resistant, they are recyclable, and well, there are also, of course, there are some offsets. Of course, you run the electrolyzer at lower temperature, but on the other hand, you also have the chance to run the electrolyzer at the lowest possible current density. And that's the other advantage or benefit, I would say, in using plastics. And the last thing is, it's very, very, let's say, easy to produce them. Now we use injection molded components, which are so designed also to assemble the gas modules, as we call them. We don't call them stacks, but we do gas modules in an automated way, fully automated production process.
It's so interesting when you describe it that way, because when I was looking at it, I thought modules can't be electrolysis, no stacks, and I had to, fundamentally electrolysis gives us hydrogen. It's the same function, but this has a pile of benefits and a pile of really eccentricity. You just mentioned one thing that is so fundamental, I want to repeat it. There's all sorts of sources of electrical energy, but when you're talking about what comes out of a solar panel, it's not been modified, it's not been converted, it's not like, 220 or 440 volts. What you have is what you could use, if you could use it directly, and that is an advantage. without any conversion. So how did you address this issue, or are your modules simply well adapted to low voltages?
Yes, this is a good question, and the answer is quite simple actually. We designed this gas module, as we call it, not to mention it's not a stack. Well, we stack cells together, but there's no, let's say, gaskets in between, so that's the reason we call it a gas module for a specific purpose and a specific market. Maybe I can answer the question as follows. We are focusing on what we call the middle market of the world. So not the gigawatt installations, also not for residential purposes, but the middle market starts somewhere, as we see it, with 150 kilowatts, and will end up in the coming years, somewhere 20 years from now, with a ceiling of 50 megawatts. And for this market has a specific purpose, but also a specific demand, looking at the people who use this kind of electrolyzers. Well, coming back to plastics, I mean, plastics have a great advantage, as I said, in the production process, the durability. Our gas modules, for example, are maintenance-free. You don't need to maintain them. You don't need to take them apart and renew some components. Everything inside, except of course of the electrodes, is plastics, and a great advantage, a great benefit, price, but also performances. And that's exactly what we see, let's say, in the middle markets. Our type of customer have a different demand, they're different kind of specifications than residential markets and what we call the top industrial markets.
It's almost as if you can draw a map. I don't know whether people are into geography here, but if you draw a map of the world and you look at the heavily industrialized areas, their first issue in getting carbon neutral is to decarbonize the industry. Not everyone has the luxury and the problem. There are some areas that don't have a simple energy supply. And it's always been the mistake that we don't have this one-size-fits-all setup of a standard electrolysis unit. We really need to adapt our technology to various areas. So this is a question in geography. Did you think in terms of where these applications geographically are necessary, existing market, easy to get there, or did people come to you? How did this development grow?
Well, in principle, we had, of course, the world in a whole as a market, but more specifically, there are many markets, geographically diversified markets, where, let's say, there's a faltering grid system. There is no electricity, there's no infrastructure. For example, remote villages or more decentralized industrial premises, which want to, let's say, run on their own electricity or their own hydrogen capabilities. And for these markets in mind, we developed our system. For example, to give you an example, the African market, which is a huge market, which has a tremendous faltering electricity system and runs more or less fully on diesel oil, which comes from very long distance to these villages or towns or whatever you call them. It would be amazing and a great advantage and a great benefit, of course, if they can produce their electricity decentralized with PV systems or windmills, and then connect one of our electrolyzers, which are scalable, very easily to connect, very durable, very simple to use, very simple to operate. And then, of course, produce low-cost hydrogen to run their, well, gensets on hydrogen to produce electricity again. So, and in order, let's say, to be adaptable to this African market, which, of course, we had it in mind, well, this electrolyzer system should fulfill certain purposes and certain requests. And, well, in that respect, we succeeded with the Xintc electrolyzer system.
It's interesting to go to a place where renewable energy is available. That is, obviously, we already learned this lesson in Germany a few years ago, but to state the obvious case, are we going to produce enough hydrogen in Germany from renewable energies in order to supply the electrical grid and also supply with replacement technology all of the vehicles and industries that use hydrocarbons with renewable energy? It's not going to happen without import of hydrogen from other areas. But there are areas that have more humble needs.
Absolutely.
And areas that have a wonderful supply of solar energy. These bring with them issues, though, right? Because you have this, sunrise and sunset.
Yeah.
And at some point, you're going to have to think about storage because people do need energy 24/7. And sometimes even the demand for energy increases towards the evening when the sun is going down. How do your units respond to the fluctuation of energy supply? Are they adaptable to the rise and fall? How do you deal with that proposition?
Well, I think that's an important issue of our electrolyzer system. They love it. They love a fluctuating, intermittent power source, actually, like windmills or PV systems. And it's quite remarkable, actually, because the PV system, they produce DC currents, voltage. So why not also using the DC directly, say, in our electrolyzers? And that's possible with Xintc. We do not need optimizers. We don't need inverters, no converters. So we also don't have curtailments. You just use the vanes, I would call it, or the cables from the PV panel directly into the electrolyzer. And whatever happens in the PV system or the windmill, it is accommodated inside of the electrolyzer, and you take all the electrons from the PV systems and convert it into hydrogen in a very, very efficient way. So it saves money, it saves hassle, it saves maintenance, it saves capex, just benefits, I would say.
And of course, you're a businessman, so the reason for getting involved in this is there's a business model out there, isn't there?
Of course, there's a great business model out there. Yes, absolutely, yes. So producing hydrogen at the lowest possible cost, anywhere in the world, for any kind of application, so 2.5 quality or 5.0 quality, either atmospheric or 350 bar, that's our ball game. That's what we are focusing on, yes.
And it's so interesting because the applications, PEM cells also have been around for ages, and there's a pile of variations there. They are off the shelf available. What is really interesting is their applications depend upon the price per kilogram of hydrogen. And by the way, ladies and gentlemen, I hate it when engineers say price per kilogram. What you really want to know is, because we can translate it, give me the kilowatt hour price once you convert it back into electricity from hydrogen, or tell me how much it's going to cost to drive 100 kilometers in my car. We need to be able to convert these numbers into rational figures that translate into what we pay right now in order to understand, hey guys, it's going to be cheaper. But this is what kills me about your technology. I find this so exciting. The idea is not to do what people talk about. So we have production of hydrogen here, and of course we want to use it for the automotive industry, so you're going to pressurize it to 350 bars or 700 bars. You have a loss of efficiency because the pressurization costs money. So here's really an interesting question. All right, once you get the hydrogen produced, do you have to pressurize it while you store it in order to keep it ready for the PEM cells, which don't need a lot of high pressure? Are you wasting energy there, or does it really flow on demand from one unit to another?
Well, first of all, we start because 70% of our market, 70-75% of the market use 2.5 quality hydrogen atmospheric, or let's say 0.5 bar. Yeah. So that's what we produce. That's what we start for. That's the first Lego block, the building block. And then, of course, you can adjust it or extend it to any quality in terms of purity, or any terms in terms of pressure, with adding more extensions. That could be done today, but also done, let's say, in a few years' time. So we are growing with the growing demand or the growing specifications of our customer base. So there's no need to define currently what you use the electrolyzer system for the coming 10 or 20 years. It is just a adjustable, standardized, modular, scalable system. And I said again, I think that is important, Brian, to emphasize. For us, in our market worldwide, it is about producing at the lowest possible cost, anywhere in the world, at any geographical locations, hydrogen, for the purpose, of course, of our customers.
When we get to, we'll return to the question of affordability, but it's also important to consider there's CapEx and then there's operating costs, right? Yeah. So there's the initial cost to buy the unit, and then, surprise, surprise, you need to have engineers visiting the unit regularly. If this is a remote application, this can be a real I won't say the word in English, but it can be a real
Yeah,
problem.
yeah.
One has to be aware of these things. And then there's also simply monitoring the device. Do you have to send your favorite engineers around to the building regularly? Do you call them on the phone and tell them to run over? Or is there and this is an IT question, which is vital to the operating costs, can you remote operate them? Do you have the IT set up in advance to make these units function optimally without visiting them on a regular basis?
I would say, it's a good question. I would say that IT is the secret ingredient in our electrolyzer system, both in the gas module, so the electrochemical process is controlled and monitored by electronics. It's very important, but also the whole system, so also including the whole balance of plants, is controlled and monitored by various power control boards, which is our own development. And as a matter of fact, we also have those 24 hours, 7 days a week remote monitoring included in the system. So there's no need to have an oil man or an oil woman walking around the electrolyzer system when it is even installed remotely. There's no need for it. I mean, OPEX, when it comes to maintenance, it comes down for every 2 or 3 months just to exchange some filters, and once a year, let's say an inspection and do some maintenance work, and that's it.
I'm thinking on the fly here. Of course, we'll have to return to this question of remote production and of energy, because this will be vital in smaller communities with electric cars at some point. The grid just cannot handle the number of vehicles here. But there's a number of things that bring us back to this question of efficiency. There's always some efficiency noodle in the room who wants to tell you how inefficient this technology is. One of those surprising inefficiencies is the solar panels themselves. They only get 50% of the sun's energy. Do we care if it costs less per kilowatt hour? I never know where these guys talk. They talk about efficiencies, but there's other ways of looking at efficiencies. A low temperature operating electrolyzer unit means you don't have to worry about trying to harvest the heat you're producing if it's a high temperature operating unit, because it's not significant in the loss of energy.
Correct.
When I return back to this question, so I'm really talking about, I don't know whether you have figures, it's hard to calculate. What is the cost of a kilowatt hour if there is no grid and you're trying to replace it? But the second question is, what is the cost of the kilowatt hour once these systems are up and operating? There's 1,000 ways of parsing what that means, but do you have an answer to that question?
Yeah, well, I will mention some figures, because that's exactly what is everybody hassling around to mention some numbers. The real numbers are, and of course, depending on the circumstances, the climatological circumstances, and the load you're running the electrolyzer on. The lower the load, the more efficient. The higher the load, the more energy consumption. But I would say that including the whole balance of plant on full nominal speed, including power supply, system control, everything included, we run the system between 52 kilowatt hours a kilogram and 60 kilowatt hours a kilogram. Everything included, and I think that is very, very competitive. If you look at the real numbers, I mean, if I should compare all the data compiled up in all those marketing leaflets, well, we're not doing it great, but these are the real numbers, and I think for lots of applications in the world, this is extremely competitive.
It certainly is. There's so much else we can talk about. The question of affordability is only one issue. But what I really want to encourage everyone to do is visit the booth, because these things are very, very attractive units. It's very easy to see at the display there.
And feel them,
Yeah, how they're integrated into a sort of a combined unit, the modules themselves. And it's unbelievable. This is the first time I've ever had contact with anything in the field of electrolysis that is not based on standard parts but plastics.
Yeah.
So I congratulate you on that.
Thank you, Brian.
Unfortunately, we've run out of time, but I want you to visit Wilko van Kampen, who's CEO of Xintc at B21 around the corner.
Yeah.
And continue the conversation there. Wilko, it's been a pleasure talking to you.
Thank you too.
Hope to see you back next year.
Okay, thank you. Thank you.
Thank you.
Thank you for your attention.